Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Razil Marushdam bin Muhammad Rashid, MA18114. Today, I will discuss about the introduction, experiment 5, determination of performance and efficiency of Pelton turbine. Firstly, the background. The Pelton wheel is one of the most powerful water turbines available. Lester Alan Pelton patented it in the 1870. Unlike a conventional overshoot water wheel, the Pelton wheel derives energy from the impulse momentum of flowing water. Many older impulse turbine designs existed, but they were inefficient compared to Pelton's. Pelton's pedal geometry was created so that as the rim runs at 12 times the water jet level, the water lifts the wheel at relatively slow speed, absorbing nearly all of the energy and making for a very powerful turbine. Next, problem statement. Pelton wheel turbine operate on the concept of changing of trajectory of high velocity fluid in a motion to produce an impulse force that causes the turbine's blades to rotate. The fluid kinetic energy can be decreased as is the Pelton wheel. Prior to joining the wheel through a nozzle, the fluid pressure head is changed to velocity head. For the objective for this experiment is firstly, to calculate specific power on the shaft, hydraulic power efficiency of Pelton turbine. Secondly, to determine the performance of efficiency of Pelton turbine. Lastly, for the scope, there are curves that can be used to determine the precise output behavior of turbines under various operating conditions. The curves are drawn from the result of experiments carried out on turbine under various operating conditions. Speed, head, discharge, power, efficiency, and gate opening are all variables that can be changed during a turbine test. The operational characteristic curve of Pelton turbine are obtained by plotting the rotational speed against both the power output and the efficiency, while the flow rate and pressure of the Pelton turbine are kept constant.
Assalamualaikum and very good morning to everyone. My name is Muhammad Amir Kabi Azmin. Today I would like to present about report about Pelton turbine. First, I will explain first about chapter 2, which is theory. Pelton turbine could be a pure impulse machine, as we have a tendency to know. Impulse force is made by water jet is high once jet has high speed. Jet velocity is high when water is held on a high altitude. This is often the explanation why Pelton turbine is best suited for operation. When water is stored at high altitude, we can perceive why there's a nozzle fit at water jet injection portion. Nozzle will increase velocity of jet further, therefore will aid in effective production of impulse force. The input power, output power, and efficiency of the turbine is calculated using the subsequent equation. Input power equal to Y QH, output power 2 pi NT over 60, where T is F times D over 2. And lastly, efficiency equal to output divided by input.
Assalamualaikum warahmatullahi wabarakatuh. I am Khairun Adhani binti Khairun Nizam. My matrix ID is MA18102. I am from Pahang. Today, I will be explaining chapter 3 for the fifth experiment, which is Pelton wheel turbine. The aim of the experiment was to study the power output produced from the force exerted on the buckets, which are later generate torque, which causes the wheel to rotate. Tachometer is used in this experiment to indicate the maximum revolution per minute of the water. The procedures below are the procedures for the Pelton wheel turbine. Number 1, the apparatus is positioned in the working channel of the bench and is connected to the bench supply using the quick release connector. 2, the tachometer is clamped into the clip provided. 3rd, band brake assembly is lifted until it is cleared of brake drum. 4th, the bench pump is switched on and the bench control valve is opened fully. The sphere is adjusted until the maximum revolution per minute are indicated on the tachometer. Fifth, the band brake assembly is lifted over the brake drum and is adjusted for a range of readings on the spring balance. The spring balance and the tachometer readings are recorded for each and brake settings. 6. The flow rate is measured using a time volume collection. Then the reading from the inlet pressure gauge is recorded. 7. Using the sphere valve, the flow rate is adjusted and the experiment is repeated. Continue doing this until you have sets of reading for a variety of different flow rates. Lastly, the graph is plotted for each of the flow rate. That's all from me. I will pass chapter 4 to my friend. Thank you.
Hello and Assalamualaikum. My name is Muhammad Hafiz Adnin bin Zaharuddin and my metric number is MA18081. I'm currently living in Kuantan, Pahang. So I'm going to talk about the result and discussion. So for fully open nozzle, we use this volumetric flow rate formula to get the volume. We were given the volumetric which is 30.9 liter per minute, and then we substitute it into the equation and get a volume of 1854 liter. After that, this data will consist of rotational speed, moment on shaft, power input, power output, and efficiency. By using rotational speed and efficiency, we plotted a graph, rotational speed versus efficiency, and this is what it looks like. So for power curve, we use the same previous formula, but this time the volumetric given were 18.75 liter per minute. We substitute it back into the equation and get volume of 1125 liter. So this is the table that we have measured that consists of rotational speed and power output. By using that table before, we plotted this graph where rotational speed versus the power output, and get this kind of graph. So for the discussion, I'm going to talk about the difference between Pelton turbine and Francis turbine. For Pelton turbine, all the available fluid energy is converted into kinetic energy, while for Francis turbine, only a portion of fluid energy is converted into kinetic energy. Second, blades are in action only when they are in front of the nozzle, but for Francis turbine, blades are in action all the time. Third one, water may be able to enter a part or whole of the wheel circumference, but for Francis turbine, water is admitted over the circumference of the wheel. Fourth, the wheel does not run full and air has free access to the buckets. For Francis turbine, water completely fills the vane passages throughout the operation of the turbine. Next, unit is installed above the tail race, while for Francis turbine, unit is kept entirely submerged in water below the tail race. Next one is there is no loss when the flow is regulated, but for Francis turbine, there is always a loss when the flow is regulated. And for Pelton turbine, it has more hydraulic efficiency compared to Francis turbine. It also requires less maintenance work uh, and need low discharge of water, opposite to the Francis turbine where it need high discharge of water. And last but not least, water flow is tangential to the turbine wheel, while for Francis turbine, uh, the water flow in axial and radial to turbine wheel. That is all from me. Thank you.
Next is Chapter 5, Conclusion. Finally, we learn how to develop a complete method of measuring fluid flow. We have learned to determine the performance and efficiency of Pelton turbine under different operating conditions. At the same time, various parameters such as height, pressure, power, and efficiency. The study compared the two situations. There are two modes of operation, nozzle fully open and power curve. It can be concluded from the experiment that a fully open nozzle is less effective. This is because the low speed generated in the nozzle causes the Pelton wheel to rotate at a low speed and cause a low angular velocity. The low angular velocity ensures that the torque on the Pelton wheel is small. As we know, torque is directly proportional to power output. The lower the power of the Pelton turbine, the lower the efficiency when the nozzle is fully open. The efficiency loss in the system is very small. The efficiency loss is caused by the mechanical friction, air resistance in the bucket, and friction in the bucket, and the nozzle loss. Therefore, various losses must be avoided in order to create a system with minimal loss and best efficiency.